I want to start by remembering Boo Armstrong, whose funeral we went to on Thursday. Boo, she was for a short period the head of the Prince's Foundation for Integrated Health, and sponsored by them she did the Northern Ireland project that showed that you could deliver acupuncture and osteopathy, etc., to NHS patients via their GPs, and they liked it. They liked it a lot. She developed a breast cancer which was so aggressive that nothing works. Well, that's not true. She got a couple of remissions with choline toxins, interestingly. But despite that, she was gone in 18 months from diagnosis. Horrible. So you can't win them all with anything. So what I do is ecological medicine. That's a systems approach, if you like, to health. It looks at the interactions between the individual and its environment. So inputs such as nutrition and environmental toxicity, and of course lifestyle and things like that, and the way we process it, and of course not forgetting our output to the planet, because if you don't look after the planet, how can you look after the individual human being? It's an interesting time at the moment because there's a lot going on, particularly with these disorders, of which we've got an epidemic at the moment, and there really is an epidemic. So this is all malignancies, England and Wales, from 1971 to 1999, 16 years, and is the increase of about 50%. Some go even worse. That's non-Hodgkin's lymphoma, and that's more than doubled, as you can see. Allergies are doing the same sort of thing. This is admissions for allergy. So that food from 1990 to 2003, food allergies went up 5 times. Now, some of that could be due to better diagnosis, but anaphylaxis went up 7 times, and I don't see how that can be due to better diagnosis. There unquestionably is an increase. There's also an increase in things like Alzheimer's and indeed the other neurodegenerative diseases. The question is why? Human genome hasn't altered in that time. One thing that has altered is the environment and the poisons that are in it. If you think about it, 150 years ago, say, waste was just natural stuff, and you know, the dirt that you found in your house was mostly your own skin debris and fabric, pieces of fabric and so forth, you know. Nowadays it contains, all waste contains a horrible cocktail of toxins, and even inside the home there's, you get a film with cooking oils and petrol-based oils, and so form a film on all surfaces which dissolves all the toxins in it. So the actual surfaces are now more toxic than they were, you know. You know, the theory about, oh, allergy is due to a little bit of too much hygiene, you know, and a little bit of dirt does you good and so forth. Problem is, dirt ain't what it used to be. And so we did this to ourselves. It's hard to see whether it can be undone now. The average person's body carries about several hundred synthetic chemicals, all of them completely new. We have no way of characterizing this. And of course the highest dose is received early in life. Firstly, kids are exposed more because they're crawling around on the floor and sticking things in their mouth and so forth. Secondly, they're exposed much more per kilogram of body weight, because you know, it takes one hand and one mouth and so forth to get that stuff in, but there's a lot less body there to lose it in. You look at something like mercury, and in 1995 they estimated there were about between 5 and 7 tons a year going into the waste stream just from dental premises in the UK. Now, I'm sure they're taking more care of it now and so forth, but that doesn't mean that it's taken care of all along the line, because if you look, where I work part of the time in York, you go into town, you go past the district hospital, it's in the suburbs of York, and there's a great big incinerator at one end with a chimney. God knows what they burn in there, but I mean it's going to be all the clinical waste from the hospital and so forth. It's rich in things like mercury and other toxins and so forth, and that's not going safely into, well, anywhere. Not that there is anywhere safe to go anymore, that's the point. There's no way anymore, is there? It all comes back to bite us. And we used to think that it was a nice, logical, straight line dose response thing, you know? As your dilution, your level of toxin goes down and down, eventually the effect reaches zero. It's the no effect threshold. But that doesn't work anymore, because we discover that there's another spike way down here in the parts per trillion. In fact, the peak typically is at around 100 parts per trillion. So that's 10 to the minus 10, 1 part in 1 and 10 noughts, which is scary. That's not much stuff taken to have an effect. This is the cell signaling that it deals with. And we've heard about cell signaling already today. And when the system is already disrupted by things like lack of vitamin D and so forth, that mean it's not working very well, then you get a big signal like this in, and you know, you get even further disruption. In the 60s, several things happened. In 1966, Kenneth Boulding wrote about the coming spaceship Earth, as he called it, and about the wilderness mentality, better known as the cowboy mentality. The idea that once you messed up this campsite, you just pack up and move along to another one. But we can't do that anymore. There's nowhere else to go. Number 2, Apollo 8 sent back this image from space. It was the first time we saw ourselves, first time we saw our home. But that did more to stimulate ecological thinking and so forth than anything, any millions of words. You know, we just looked at that and thought, wow, you know, it's not infinite. It doesn't go on forever. It's just a little place, really. And 3, actually it's 4, 1966. I started med school that year. And also, that year, Heinrich Otto Warburg, he had got the Nobel Prize in 1931 for the start of the description of mitochondria and their function. And he gave a lecture to the Nobel laureates place on Lake Geneva, and called The Prime Cause and Prevention of Cancer. This is what he said. Prime cause of cancer is the replacement of the respiration of oxygen in normal body cells by a fermentation of sugar. Now, as we'll see in a moment, the respiration of oxygen, that's mitochondria, that's what they do. Okay? No cancer cell exists, he said, the respiration of which is intact. And also he remarked that most experts agree that nearly 80% of cancer could be prevented if you could get rid of all the known carcinogens out there. So let's look at mitochondria. They're the little like batteries within cells, and the more work a cell does, the more it's going to have. So this is, these are heart muscle cells with big masses of mitochondria in them. Okay? And a sperm is kind of like a rocket, really. It's just there's a payload in the hair, in the nose, there's a tail for propulsion, and there's a whole load of mitochondria to provide energy to the tail, to provide the fuel or whatever, and that's it. There's nothing else to it. All it's got to do is deliver that payload. These are the things that it is thought were a separate organism that learnt how to live within other larger, more primitive cells called archaea some tens of billions of years ago. And they're quite different from other cells and from, you know, the rest of our cells and so forth. For a start, they have a double skin around, and that has a particular purpose. Secondly, they've got this weird circular DNA, but they have just one single circular chromosome, like that, although they also need genes from the nucleus of the cell, because these are the complexes in the wall of the mitochondria, and only the ones that are in colour are coded for by mitochondrial DNA. The rest of it has to come from nuclear DNA. It used to be, a few years ago, everything was about inflammation. We've heard several times about inflammation today. You know, the next few years, it's all going to be about mitochondria. And so we'll get, accusations, oh, but you can't apply this sort of stuff to everything. Well, look at the list of diseases that have already been associated with mitochondrial dysfunction. There's cancer, there's Alzheimer's, Parkinson's, schizophrenia, non-alcoholic steatohepatitis, fatty liver, cardiovascular diseases, fatigue, fibromyalgia, whole darn shooting match, really. What they do is this. They use oxygen to produce energy much more efficiently. The pathways of respiration, the ones that happen outside the mitochondria, just produce 4 molecules of ATP, which are the units of energy inside cells, whereas the respiratory chain in the mitochondria produces 34, so it's a heck of a lot more efficient at energy. You remember aerobics? Well, some of you will. The point was that you worked your exercise until you felt the burn. The burn was you exceeding your mitochondria's capacity to keep up, and therefore the body having to revert to the less efficient anaerobic form of energy production, which converts glucose into lactic acid. And it's the lactic acid that gives you the burn. These are the double layers, and this is the inside of the mitochondria. So that's the outside in the rest of the cell. And there are these complexes that build up hydrogen ions, protons, inside there. So it is a battery, a capacitor, right? And then they get popped out through complex 5, and every time a proton goes through there, it clicks the molecule round through 120 degrees, and that produces another molecule of ATP. This capacity here is all producing ATP there, and then this goes out through another molecule called the translocator. It pumped out into the cell, provides energy. So you can see that if that starts going wrong, a lot of things are going to go wrong in the cell. And it's entirely plausible that cancer and so many other things that we saw listed there would be the result of mitochondrial dysfunction. Wahlberg said, therefore we propose first to remove all the compact tumours, so surgery. So here we are, we're integrative still. Then the active group should be added to the food in the greatest possible amount for many years, even forever. By the active group, he means the key nutrients needed for this respiratory chain, as it's called, inside in the mitochondria. So that's a long list of things like B1, B2, B3, B5, magnesium, manganese, lipoic acid, ascorbic acid there for the carnitine, so on and so on and so forth, and CoQ10 and so on. Now, cancer cells, it is known that they do have fewer, smaller, abnormal mitochondria, and they also use 10 times as much glucose as an ordinary cell, and therefore they produce 10 times the lactic acid. It's that lactic acid that makes it an acid environment, and they function well in that acid environment. That's why alkalizing the cell and the environment is a thing that makes sense. So there have been a couple of books, there's been a book and a paper this year that have reminded us about Wahlberg and have referenced him and built on what he said. One is this by some people that Steve and I know quite well, and others this interesting about cancer as a metabolic disease. Well, I don't think anybody is going to argue with that theory, are they? Now, if you look here, you've got several of the active groups, as he calls them, the nutrients, are necessary in here. CoQ10, you can't see it, but CoQ10 is what transports the protons from one of these complexes to the next. And in here is glutathione or cysteine, which is its precursor. Here, your FAD, so Lowitz flavin adenine dinucleotide, is a derivative of riboflavin, B2. NADH is a derivative of niacin, B3. Well, you tend to think of these things, and ascorbic acid and so forth, basically as antioxidants. That's not quite right. What they are is they're oxidant handling tools. You need the oxygen, you need the oxidation and so on, because it's what's fueling your being alive. But it needs to be kept in control and in check, right? Let's use the metaphor that it's very hot stuff, so you need some pair of tongs or whatever to handle it with. And that's what things like CoQ10 do. Another guy called Carl Volkers, who was nominated for the Nobel Prize but never awarded it. He was responsible for isolating vitamin B12 way back. He also demonstrated that vitamin B6 is an effective treatment for carpal tunnel syndrome. And he then took a great interest in coenzyme Q10. He never managed to do any prospective trials, but first what he did was he followed a group of patients, and they were people with diagnosis of cancer, 6 of them, 4 with lung cancer, 2 with breast. All of them were given coenzyme Q10 for heart failure, right? And at that time, we didn't know much about it, so people were trying out different doses and regimes and so forth. And the dose that they got was a big one. All of them had remissions of their cancer. Now, it's not big numbers, but it's a pretty striking percentage result, isn't it? 100%. Then he managed to do a study with William Judy in Florida. He took 30 people with cancer of the prostate, 15 without metastases, 15 with metastases. Again, gave them coenzyme Q10, and the dose, by the way, is 500 milligrams a day in this, which is a lot more than any of us have been giving normally. I mean, most of the available pills are about 30 milligrams a day. And so he gave them 500 milligrams a day. Of the ones without metastases, all of them saw their PSA normalize. Of the ones with metastases, just over half saw their PSA go to normal. So that's an impressive result as well. Sadly, of course, there isn't, it's not worth investing in, so no further studies have really been done. We ought to have a word here about statins, because this is taken from a website called spacedoc.com, which is a guy called, I think it's William Graveline, who was one of the US astronauts and was a doctor. I think he went to space 3 times, actually. But he takes a great interest in this, and he makes the point that statins block the synthesis of cholesterol, which in itself is probably a rather bad thing to do, actually. But it's also bad because it's the pathway to a bunch of other stuff, including coenzyme Q10. So this is now a recognized thing that, a lot of people say, right, take statins, then you must take coenzyme Q10, and it will reduce or even block the side effects that are common with coenzyme Q10. However, there are other issues going on here as well. Vitamin C, there are 2 levels you see here, and I'll explain in a moment. Vitamin C also supports mitochondrial respiration, and it is an antioxidant, if you like, and it also has striking epigenetic effects. It actually influences the switching on and off of genes, nearly 2,000 of them. We used to think the vitamins, like the B vitamins in particular, were basically they're cofactors for in enzymes. So you stick the B6 in there, and that enzyme, it makes it work. Well, they do that, but they're also epigenetic agents. They switch genes on and off. So, Linus Pauling and Ewan Cameron, up in Scotland in the 1970s, they took terminal cancer patients, in the sense that the doctors had said, sorry, there's nothing else we can do for you. And they gave them 10 grams of vitamin C a day. Firstly, intravenous for the first couple of months, and then orally thereafter. And this, if you plot out, is the survival curve that they got. So I've put a couple of marks here. The green ones are the controls who didn't have the vitamin C, and there's 1,000 of them. The blue one is the ascorbate treated, and there's 100 of them, right? This mark here is when the controls hit the 50% point, and that's at about 40 days, so 6 weeks, right? Here is where the ascorbate group hit the 50% point, and that's about 110 days. So that's more than doubling. It's getting on for a tripling of the survival time. A guy called Myrtle at the Mayo Clinic did a couple of alleged reproductions of this and said that it doesn't work. And there were, I never understood why the argument about it got so complicated, because it's actually very simple. They didn't carry on giving the vitamin C. They gave it for an average of 10 weeks, okay? So that's there, that's where 10 weeks is, that's why I put that line in. You can see the, you know, if you give it there, then that curve's soon going to come down and join the other one, isn't it? Abram Hoffer, God rest his soul, in Canada, took it a step further. Now, these are not terminal patients, but they are patients with a diagnosis of cancer who came to him and said, you do orthomolecular medicine, is there anything you can do about it? And so he gave them vitamin C at around the same dosage, plus zinc and B vitamins, and that's it. So he upped the game slightly, but he got a much better result. You look at that. Again, the control group is people who he encountered and therefore was able to follow up, but who declined to do the program. And the treated group had 97 and the controls there were 18. But this is, look, this is going out to 5, 7, 9 years. So that's made a real difference there. So each of these things on its own or in small group of things can make a worthwhile difference. Why do mitochondria malfunction? Well, it's going to be an interaction of those two things, of the toxic damage and the lack of the nutrients. We live in a world in which the toxins are just building up all the time, and a lot of the nutrients are depleting as we speak. There's good data on the level of selenium, including in the UK, plummeting, from Margaret Raymond at University of Surrey. And if you plot that curve and plot the curve of sperm counts in males, they go exactly parallel. My colleague Stephen Davis coined the concept of the nutrient-toxin interface, and he cited as prime example the case of thalidomide, where in laboratory experiments, because nobody's going to have done this on humans, in a laboratory, if you give thalidomide to healthy, well-nourished rats or mice or whatever, their offspring don't have malformations. If you make rats or mice deficient, particularly in B vitamins, riboflavin and so forth, you don't give them thalidomide, they get malformations. If you make them deficient and give them thalidomide, they get even more malformations. So it's all about the interaction between the two. The more toxins you're exposed to, and we live in the 21st century, for God's sake, you know, there's all these machines beneath us have been pumping out toxins into the environment for ages, and so the more we're exposed to, the more nutrients we need to handle it. And one of the things we need it for is to preserve our mitochondria. Now, we can look at this stuff now. This is looking at the surfaces of mitochondria, and it's using fluorescent probes and other things. It's kind of CSI stuff, you know. In fact, the first database that they used to use for it was the Ohio State Department of Justice, their forensic database. You know? So the forensic guys drove the science, and then some bright people have picked it up. This stuff here, malondialdehyde, which is also this one here, the aldehydes, is a known lipid peroxidation product. It's the result of free radical or oxidative damage to lipids, to membranes, to the oils that make up our membranes, in this case the mitochondrial membranes. You can see that it's having a consequence here. The mitochondria have poor structure, they're clumping together, that's all abnormal. They're dysfunctioning mitochondria, that much is clear, right? Also, the pH is marginally low, so they're getting to the acid side already. Now this is a cancer patient, by the way. This is non-cancer, and we've got a different pattern of damage here. So there's only a little trace of the malondialdehyde, that's no big deal. Here we've got a couple of chemicals. Paradichlorobenzene is the smell of mothballs or of those toilet blocks. All right? It's a recurring theme. We keep seeing it in people's cells, you know, surprisingly toxic. Well, I mean, it's meant to be toxic to germs and to insects, so why would it be good for us? Dichloroxylenol is a bacteriostatic and mold inhibitor thing. There's not a plain free radical sort of problem there, but the same sort of consequence in that that environment has gone distinctly acid. This is an interesting one, because the other place that we look for these chemicals inside cells is adducted to the DNA, to the genes. Okay. This is a young lady with supposedly hereditary thyroid cancer, which is an unusual cancer because it's supposed to be 95% cure rate simply by removing the thyroid. That's all you have, all the treatment there is. So she came to me and said, I don't want to do that. And I said, well, look, I think you must. You know, I took some advice from other people and said, I think you've got to, really. And he said, well, my oncologist says I don't have to do it now, so I'd like to try and see what we can do. So we ran some tests. We got this. We got polyoxyethylene on the p53 gene. And p53 is amazing. You mentioned it before, a couple of people, didn't we? It detects DNA damage, and it stops the cell from going into the division phase. And then it calls in the repair enzymes like DNA methyltransferase and so forth to work and repair the DNA. And if this can't be done, then it causes apoptosis in the cell, programmed cell suicide. All right? So if you've got a chemical on the gene for this vital enzyme, then that will inhibit the expression of the gene, the production of the enzyme, and it's likely that function is going to be lost. Ribonucleoside, well, no. The chromium peptide complex is on a PPAR gamma gene. PPARs are very interesting. It stands for peroxisome proliferator activated receptor. Now, as far as I can see, that means the peroxisome proliferator receptor. You know, we don't talk about the vitamin D activated receptor, we talk about the vitamin D receptor. But anyway, it's important for mitochondria because the peroxisome proliferator causes peroxisomes to proliferate. Peroxisomes are little tiny organisms, or what's the word, structures within cells that actually, one of the things they do is get rid of toxins, and the other thing that they do is they break down abnormally long fats into smaller units that are then transported into mitochondria by carnitine to be burned for fuel, to be burned for energy. So literally it's like chopping up the firewood. So they are vital for mitochondrial function in a couple of ways there. Right? So she's got these. We think, well, it can only be a good thing to get this stuff off of her genes and her, well, it's mostly on the genes, actually. And so that one was in January, and this is in July. So it's gone right down, and that's all very good. But there wasn't much more I could say. What I didn't expect was the ultrasound results that she got in August. The previous ultrasound in December just gone said there's a large primary lesion in the lower right lobe of the thyroid here, and there's a whole, great big long list of dodgy looking nodes just outside the thyroid, lymph nodes there, right? The August one said there are no abnormal lymph nodes at all, and the primary is halved in size. Now, I don't know what we're doing here, and I'm certainly not suggesting that this is, proof that it's going to happen all the time or anything like that, but it's certainly exciting times for us and very interesting. You can see from that the treatment priorities here are going to be, number one, avoid sugars. Number two, feed the mitochondria, give them what they need to restore normal function. And arguably, number three, remove the toxins, although it depends when somebody comes to you. I mean, I'd love to be able to say to you, oh, lots of people come to me in the early stages of cancer and we remove the toxins and they're much better. Doesn't happen. This is the real world, What happens is they come far too bloody late when, 3 other treatments haven't worked. And then what are you going to do? I mean, you haven't got time for them to get all their fillings out. You've got to keep them alive first. So we get to do the basics, really. So, is there a conflict between antioxidant or oxidant handling, supplementation, and chemotherapy? Well, there have been, as I think you said, Patrick, there have been a whole load of studies on this lately, but the one, I don't think you need more than these two. If you go to PubMed or one of the outlets and look, Block, B-L-O-C-K, and Koch, C-O-C-H, 2007 or 2008, you'll get these two papers. So first paper was the impact of antioxidant supplementation on chemotherapeutic efficacy. What it said, none of the trials that they allowed in the end, which was only 19, this is a pretty rigorous elimination, none of the trials reported evidence of significant decreases in efficacy from antioxidant supplementation and chemotherapy. Many of studies indicated that the treatment resulted in either increased survival times, increased tumour responses, or both, as well as fewer toxicities and so forth. The second one, next year, impact of antioxidant supplementation on chemotherapeutic toxicity. The majority, 24 out of 33 studies, reported evidence of decreased toxicities from the concurrent use of antioxidants with chemotherapy. 9 studies reported no difference in toxicities between the two groups. Only one, which is on vitamin A, reported a significant increase in toxicity in the antioxidant group. And the reason for that is fairly easy. I mean, there's several other studies that have shown, like the CORET and the, what's it, ABTC or something, trials that showed vitamin A to be a bad thing. It's because it's exactly parallel to vitamin E. We just don't get it. We haven't got it, right? Vitamin E, the standard vitamin E is alpha-tocopherol. But in real life, that isn't what happens. In food, you get alpha-tocopherol, delta, gamma, a whole host of tocotrienols and so on. They all make up vitamin E. In vitamin A, likewise. I mean, vitamin A and carotene probably competes with all the other molecules that we're now taking an interest, like lutein and so on and so forth, the colourful veg stuff. All right? And if you give loads of this, you're probably crowding out all the other ones. that would be a good idea. So it's, you know, it's done. But that's the only way that they saw an increase in toxicity. So you don't need any other papers. I think these two are enough for you to say there is no adverse interaction between nutritional therapy and chemo. Indeed, there are beneficial interactions. Why aren't we doing it? You know, why should people have to choose between the two? This supposedly is the strength of the supportive evidence from clinical studies for benefit of nutrients and herbal preparations in cancer. This is the worth it line. Above there, it's worth doing. Vitamin D looking big there, antioxidants looking good here, green tea, everybody loves green tea. Folic acid, well, there are some problems with folic acid as well, including that there's some evidence that if you give occasional or one-off doses of folic acid before chemo, you may actually have an adverse effect. So this sort of stuff ought to be done by people who know what they're doing. So we had a conference in June, and we had Gary Deng from Memorial Sloan Kettering in New York to come over. He's a former president of the American Society for Integrative Oncology, and he works in the integrative oncology. MSK is a specialist cancer hospitals, right? And the New York one has an integrative oncology unit with a staff of over 40. Staff, see it, there's nearly as many people as in this room, for God's sake. There's Gary. They've been doing vigorous research on a load of stuff, largely on symptom control, though there is a little bit of direct therapeutic anti-cancer effect research going on. But anyway, he inspired us, so we are in the process of setting up the BSIO, the British Society for Integrative Oncology. The website is about to go live any day now, and that's the web address. Okay, that's all, folks. Thank you very much.